All right, so here we're looking at frequency distributions. So after the data have actually been collected from a sample of the population, the next task is actually to present the data in a condensed and manageable form. So in this way, the data can be more easily interpreted. Suppose, for example, the researchers are interested in determining the age at which adolescent males show the greatest rate of physical growth. So a random sample of 35 10-year-old boys is measured for height and then remeasured each year until they reach 18. So the maximum yearly growth for each subject then would be maybe as follows. So we have these numbers for that. Now, a piece of the data is called a data item. So this list has actually 35 data items. Now, some of the data items are identical. If you notice, we have, a 14 and a 14 and a 14, and, we have different ones. So we have two of them that says that are 11. And so that we can say the data value 11 occurs twice. Similarly, because five of the data items are 12, the data values 12 occurs 5 times. Now, collected data can be presented using a frequency distribution, and such a distribution consists basically of two columns of data, which we're going to see over here in table 12.2. And so we have the age of maximum growth and the number of boys with that frequency. So that's going to be our frequency distribution table that we're going to look at. And the data basically, again, are listed in a column, and then the numerical data are generally listed from the smallest to the largest. And then the adjacent column is our frequency, and it represents a number in that growth amount. So the age of maximum growth was 10. There was one of those. 11, we said there was only two. 12, we said there was five. And, like I was saying, there's 14. We saw quite a few 14s. There's 9 of those. So that's the biggest one. And then it goes back down. And then all of them added together, as far as the frequencies go, that's going to give us our total number of boys that we sampled there. All right. So for this one, what we want to do is we want to actually construct this frequency distribution for the data of course grades in a pre-calculus course listed alphabetical by the student name in the grade book. So what we have there's our course grades. And so what we're going to do is let's have a grades and a frequency column. So we know we have A, we have a B, a C, a D, and a F. Okay. Now we have to go and count them all. All right, so A's. So A is 1, 2, 3. Looks like there's 3 of those. So that frequency would be 3. Now B, 1, 2, 3, 4, 5. So it's going to be 5 of those. C. So 1, 2, 3, 4, 5, 6, 7, 8, 9 of those. D's, looks like we've got 1, 2 of those. And F's, the only thing left is just this one F, and so we have 1 of those. So now if we add that together, we have what? 10, and then there's 8, 9, 10, so that looks like 20. And if we count these, there's actually 20 of those. And so we have a matching number as far as that. So I guess if we want to, that's usually sometimes labeled as n is equal to 20. And so we could do it that way. But if you just take and add them together, that makes sure you have all of those there if you know the correct number that are here. All right, so let's stop with that and we'll come back for another one.